Section 4.3, we talk about congruent triangles. Up until this time, we just talked about congruent single dimension items, like congruent segments, congruent angles, that sort of thing. Now we're actually going to combine those congruencies of congruent segments and congruent angles into two-dimensional figures and talk about congruent triangles. Okay? Congruent triangles are represented by these two symbols right here, very short. Simply means the same thing it does with everything else. Triangles that are the same shape and size. Okay? They are the exact same shape and size. So we've got here drawn two triangles, triangle ABC, triangle EFG. Got a lot of lines on them, but notice that segment AB has a mark there. Segment EF has that same mark saying, oh wow, segment AB is congruent to segment EF. And we've got that noted right there. And then segment BC has two little marks, and so does segment FG, denoting that segment BC is congruent to segment FG. And then segment AC has three little marks, and so does segment EG has three little marks, which means that segment AC is congruent to segment EG. Okay? Now, the same thing, we have a one arc at A and a one arc at E, which says that angle A is congruent to angle E. Two arcs at B, two arcs at F, which say that angle B is congruent to angle F. Three arcs at C, three arcs at G, which say that angle C is congruent to angle G. Okay? Now, one of the things I want to show you is this. Basically, we're saying that triangle ABC is congruent to triangle EFG. If you want to know exactly what angles and segments line up, simply stack these on top of each other. So what I've done is we've got triangle ABC up here, triangle EFG is down here. Draw the lines. That means that point A corresponds to point E. Point B corresponds to point F. Point C corresponds to point G. Angle A corresponds to angle E. Angle B corresponds to angle F. Angle C corresponds to angle G. Segment AB corresponds to segment EF. Segment BC corresponds to segment FG. Segment AC is going to correspond to segment EG. Okay? Now why is that important? Well, because of this ring right here, what we call Cpctc. You're going to use that a lot. Put it on your homework, on your assignments, on your test for this chapter, and it's sort of guaranteed to make sure you get a few extra points, or to make me look the other way should you make some stupid mistakes or some silly mistakes on homework and problems. Cpctc simply says the corresponding parts of congruent triangles are congruent. So you have to know what parts are corresponding. You get the wrong parts corresponding, you're going to mess this up. The best way to do this is simply stack those two triangle names on top of each other, and you know exactly what points are corresponding with what angles are corresponding with what, and then what segments are corresponding. Okay? Introduction to congruent triangles. Pretty short, pretty sweet. Got one little other topic we need to talk about in congruent triangles, and we'll be finished. Okay, the last few things we need to say right now about congruent triangles is this. Again, congruent triangles, triangles that have the same shape and size. Congruence of triangles is reflexive, symmetric, and transitive. RST, 1, 2, 3. Congruent triangle is congruent to itself. The pieces of a congruent triangle are congruent to themselves. If one triangle is congruent to another triangle, if triangle A is congruent to triangle B, then triangle B is congruent to triangle A. Again, the same property, identical twin property. And it's also transitive. That's the identical triplet property. If I have triangle number 1 is congruent to triangle number 2, triangle number 2 is congruent to triangle number 3, then triangle 1 is congruent to triangle 3. And all of the corresponding parts. Okay? Now let's talk a little bit about something we've already been over quite a few weeks ago when we did transformations. Let's talk about congruence transformation. Congruence transformation is known as an isometry. Okay? What are the congruence transformations? Okay, we've known that. You've been tested over it. You did a good job on that. Translation, reflection, and rotation are isometries. They are congruence transformations. Now, what's the code words or the code letters that you can use on this congruent chapter? C, P, C, T, C, C, P, C, T, C, C, P, C, T, C. What does that stand for?